In this video, I'm going to be going through a development drawing from an independent trial. I think this is from 2019. So the first thing, you can see my sample answer here, and so I'm going to show you how I've come up with that. The first thing is that we're going to be making two sides of this shape. So it's a truncated, some sort of pyramid. So we're taking that side and that side. That's here and here. The first thing we're going to do is we're going to identify which of these sides are true lengths in any view. So we can say, well, this here, AE is not a true length in either view. AB is not a true length in either view because this is on a diagonal, right? Often it would be, but in this case it's on a diagonal. EB, same thing, not a true length. Okay, BC, it is a true length because it's a flat line here. That means it's a true length in this view. ED is a true length in both views. And then finally, CD is not a true length in either view. Now, the thing that is interesting about this question is that we have a lot of different heights. So when we're, often when we're doing true lengths, we have just the same height for all of our distances. All of our lengths that we're working on are all the same thing. But here, we are going to be doing a range of heights. So we're going to be going from things like B to C. And so I'm just drawing lines across. So rather than having to measure the heights to calculate the hypotenuse and therefore the true length of our lines, what I'm doing instead is I am drawing these lines to represent our heights, and then I'm using a baseline that I'm going to measure all the distances. All the planned distances will be represented horizontally on these lines. Okay, so the first thing I'm going to do is I'm just going to get all the true lengths because I know that I need all these sizes. So I've got AE. Now I'm going from A, or this is E is down here, right? So E and D are both on this line. This is the E line and the D line. This is only A is on this line, B is on this line, and C is on this line. So because I'm going from A to E, A is up here, E is down there, so this will be true length AE. So that's right, AE. Okay, the next one I'm going to do is we'll do AB. So AB, I'm going from A to B. So A is up here, B is down here, and that's going to be true length AB. The next one I'm going to do is I'm going to do EB. So I'm going to set my true length, and I'm going to go on the B line because it's a B, and I'm going to go from B down to E. And I'll write EB there. Okay, BC is a true length in this view, ED is a true length in this view, so I think that leaves only one more, which is CD. So I'm going to go on the C line, and we said D is also on the bottom line. So we're going from C down to D. This gives us CD. Okay, so now I've got my true lengths, those 4 lines, I can get started. The first thing I'm going to do is I'm going to take true length of AE. The true length of AE is this distance. I don't have to start at the start of the line, but I will, just because it's as good a point as any. And I know that E has to be at that location. The next thing I'm going to do is I'm going to find B, and to find B I'm going to triangulate. So I'm going to go measure from AB, and I know that AB has to, if AB is somewhere on that line, so B is somewhere on that line. The next thing I'm going to go is I'm going to find EB. So EB is this length. So from E, EB. Now I didn't quite draw my arc long enough. If I was under exam pressure, I might have even just guessed it, but so this is EB. So that means that where these two lines meet is going to be, if EB is on this line and AB is on this line, where these two lines meet is where B is located. And I can draw those lines in. Now the next thing I'm going to do is I'm going to find C. So to find C, I have the true length of BC in this view. So I'm going to say, well, BC is somewhere on this line. BC, and to find BC, I'm going to have to triangulate another location, right? I'm going to have to locate EC, which is not drawn on here. And EC, the height of EC, we're going to use the plan view, the plan distance is here. The plan distance for EC is this. And then I'm going to measure from C to E. E we said was the bottom line, so this is CE. That's the true length of CE. So I'm putting my dot on that point. Labeling that as EC. I don't really need to label the second one, but I do just because, you know, it helps to understand what's going on. Okay, so that's that line. Now, the next thing I'm going to do is I'm going to go CD. So CD, I've already got my, so I've located C. The next thing I'm going to go is I'm going to do CD. So to find D, I know CD, so from point C, I should label these points. This is point B, this is point C. So from C, the intersection of these here, D has to be somewhere on this line, CD. And then measuring from E, now ED is a true length, so I can just measure that directly. From E to D, ED, and I can draw that in, and that gives me my values. Now, I worry that sometimes my angles are a little off. That's because I am taking a lot of measurements and there are a lot of room for compounding error. If you're out by, we're talking about very small measurements. So if you're out by a millimeter here and a millimeter there, those things, we're taking these measurements multiple times. There's a lot of opportunity for error. The marker is not looking for that. The marker is looking to see that you have found true lengths and that you've used the method of triangulation. And I think that by labeling your arrows, your arcs, not only are you less likely to make an error, but also it communicates more information to the marker so that even if something is really wonky, the marker can at least see that you had the right understanding and you had a bad compass. We're done.